page 183. All right. Example 1. The manager at a pizza parlor surveyed her customers to find out customers' favorite toppings, and she recorded the results in the circle graph below. If the average number of customers in one day is 300, how many of those customers are likely to choose olives as their favorite topping? Well, if I look at this, it's 18% like olives. So isn't it going to be 18% of 300? How do I do that? I multiply. But 18% needs to be changed to a decimal first. Remember, you move the decimal to the left. So 0.18 times 300. And when you punch that in, you're going to get 54 people. Example 2. A vote was held for class president. 400 students voted, and 60 of these students were given an exit poll to find out which of the 5 candidates they voted for. The results are shown in the circle graph below. Based on this data, estimate the total number of students who voted for Kaito. Now, let me tell you something. Guys, this is real. When there's an election, if you watch election night coverage, this is what they do. They go and stand out of a poll for a half hour, and they survey people coming out. Who'd you vote for? Who'd you vote for? Who'd you vote for? And they record their results. And then they use those percents to make predictions on how everyone is going to vote. We're going to talk about this 2 ways. So, it said, we want to know, estimate the number of students that voted for Kaito. Or Kiko, sorry. How many people voted for Kiko in this survey? 14 out of 60. I'm going to show you 2 ways to do this. Divide 14 by 60 for me. What do you get? What percent? 23%. So, if 23% vote for Kaito, can I then just do 0.23 times 400? And if you do that, you're going to get 92. So you can find the percent, and then do percent of the number like we just did. I wouldn't do that. Okay? This is what I would do. I love proportions. If you can say this is related to this, as this is related to this. So, didn't 14 out of 60 say they were voting for Kaito? We want to know X out of 400. Right? Does that make sense to you? If 14 out of 60 said they were voting, we want to know X out of 400. How do we solve a proportion? We cross multiply. So, I'm going to do 60x equals 5,600. Divide both sides by 60. I hope my math is wrong because I'm doing it right in my head. You should get 92. Because, you know why? Because we rounded. That is another great reason why a proportion is even better here. Because we're not, whenever you round in the middle of the problem, things are going to be off a little bit. Okay? Because this wasn't exactly 23. Okay, let's look at example 3. Jasmine surveyed her friends to find out what type of books they read for a book club in June. The results are shown in the bar graph below. Based on the bar graph, predict the number of mystery books that Jasmine's friend will read in July if the total number of books is expected to be 72. So, they're saying in July, they're expecting to read 72 books. What do you think the first thing I need to do is? these are the books in June. Let's figure out how many total books were read in June, right? Total for June. So, nonfiction is 9, plus science fiction is 10, plus this is 4, plus this is 8, plus this is 14, plus this is 11. And if you add that up, you are going to get 56. So, how many mystery books did they read in June? 14 out of 56. We want to know how many mystery books they're going to read in July. What's the other half of my proportion going to be? What's the other half going to be? X out of 72, right? We know it's 14 out of 56. If it stays the same, it'll be X out of 72. Cross multiply. And I'm going to have 56X equals 14 times 72. 1008. Divide by 56. And you get X is 18. Now, is that going to be exact? No. It is a prediction based on what we already know. All right. Here we go. Heather wants to gauge interest in forming a new school club. She conducts a survey to find out how many students would like to join one of 4 proposed new clubs, and the results are shown in the bar graph. If there are 280 students in Heather's school who are looking to join a new club, estimate how many of these students would be interested in chess club. Well, first of all, we need to figure out how many people were surveyed. Okay, so the number surveyed, let's see, 15 plus, I'd go with 23. But again, this is going to be an estimate, right? I'd say that this is 22 plus 13. And if you add that up, you get 73. So, who can give me my proportion if we want to know how many kids we think are going to sign up for chess club? Nick, what do you think? Correct. So I'm going to have 73x equals 23 times 280 is 6,440. Divide both sides by 73. X is, it's not 88%, it's 88 people. If we want to know what percent it is, look, wouldn't my percent be here? Nick, if I wanted to find the percent, I would do 23 divided by 73 is, it's about 31.5%. Okay? I could have also done 0.315 times 280. And I would have gotten about the same thing. All right. Line graphs and scatter plots. Now, a line graph shows time over, or change over time. This is what we call a double line graph. How many more tires do you think store A will sell than store B in 2009? Now take a look. Look at our years. 2008 is here. 2009 is off our graph. But the key here is figuring out what the rate of change is. These are linear graphs. They have what we call a constant rate of change or a constant slope. We're going to learn all about that this year. How much is store A, which is the dashed line? How much is that going up every year? So this is about 15,000 to 17,000, 17 to 19, 19 to 21, 21 to 23. So about what is that going up? What? 2,000 plus 2,000 per year. Okay? Store A, its rate of change is positive 2,000 per year. This one is not going up quite as fast. But from here to here, it goes up 2,000. How many years is that? 4 years. So how much is it going up per year? Yep, this one is going plus 500 per year. Does everybody see how that is figured out? So, if in 2008, store A is at 23,000, what will it be in 2009? It'll be at 25,000-ish. And what will store B be at in 2009? It's at 14,000 now, and it's going up about 500 a year. What's it going to be? Okay. How do I figure out how much more this is than this? I subtract. And when I subtract, I'm going to get 10,500 more. Now, is that going to be exact? No, but it's a pretty good estimate. All right. I'm going to skip this one for now. Actually, a scatter plot compares two sets of data that are written as ordered pairs. This is hours studying for a test and your test grade. Does it make sense that down here, this is low hours, means a lower test score? The more you study, the higher your score. If I drew a line of best fit up the middle of this data, it would be a line that is going up to the right. That is what we call a positive correlation. When one set of data is going up, so is the other. Positive correlation. Up. Like when you're reading from left to right. We're going to talk a lot this year about slope, and this is also a positive slope. This set compares size of car to miles per gallon. You probably don't know a lot about this, but the smaller the car, because isn't this a smaller number, the higher the gas mileage. The bigger the car is, the lower the gas mileage. So as one is going up, the other is going down. If I did a line of best fit, it is a negative correlation. Then, you have data that looks like this. The hours at a shopping mall and the amount spent. Some might argue that the longer you're there, the more you spend, but you could just be going there for lunch and hang out with your friends and not spend anything. Right? You could be there all day and spend nothing. So, if I plot these points, they're all over the place. Is there any line of best fit? There's no trend. It's just all over the place. This is no correlation. There's no relationship. If you were watching this at home, pause the screen, and there's the answer to example 3. All right, example 4. The scatter plot shows the number of hours spent studying for a final test, and the test scores are several students. Now, I have a question for you. What is the correlation there? Positive correlation. It is going up, right? You see that? So, I would draw a line of best fit. And later on this year, we are going to find out how to come up with an equation for the line of best fit. But right now, when you do your line of best fit, first of all, please use a pencil when you do this. Because if you do it with a pen and you need to move it, it'll be a mess. You want to try and get your line so there's about the same amount of data above and below. So I would draw my line of best fit like that. Do you agree that there's about the same amount of points above as below? It's kind of right down the middle. So we're going to use this line of best fit to make a prediction. So